Hello students, hope you all are fine and safe at your home. First of all, I would like to congratulate you for your wonderful result in class 10th, and also I welcome you all to class plus 1. Today, as you all are knowing, my subject is maths and myself Shiba Ramesh teacher. So today we are going to start chapter 1, sets. So before going to start sets, we should know what is set and what is the difference there. So first, just I am writing some names there. You just check it, huh? Some names I am writing. So all have checked. Here I wrote some names like Sachin, Mohanlal, Bill Clinton, Usha Uthup, Sonu Nigam, Nivin Pauly, etc. and so on. This is a collection of names. At present I wrote some names. So at present we will say it as a group or collection of names. So now by seeing these names, can you tell me whether Sania Mirza I will write in this or not? By seeing the pattern, whatever I wrote there, so can you tell me whether Sania Mirza will be there in the collection or not? Not confirmed. Okay. So whether Mammootty will be there in the set or not? Cannot say, because here I haven't defined a particular rule there. Gradually I wrote some names there. They might be actors, they might be politicians, anything there. But if the same collection, I'll write in this way. So now I am going to write in this way. I am not going to write the full name there. It will be difficult for me to write everything there. So here some names I wrote there like Sachin, Yuvraj, Dhoni, Virat. Okay, here I made a collection. This one is a collection there. Now can you tell me whether Suresh Raina will belong to this collection? Whether it will belong to this collection? Yes. Why? Because here the names which I wrote, what are they? Yes, they are cricketers there. So if I am saying Suresh Raina will be there in this collection or not, then yes, Suresh Raina also will be there in the collection. So what is the difference in this one? The first example which I wrote and the second one. In the first example, gradually I took some names there. They are actors, they are cricketers, they are politicians, they belong to different jobs there. But here, I specified there. Here, the names which I wrote, they are cricketers there. So if I say whether Kapil Dev will belong to this collection or not, then we can say yes, Kapil Dev will belong to this collection. If I will say whether Mammootty will belong to this collection or not, then no, definitely we can say Mammootty will not belong to this collection. So that is the difference between a group and a set. A set means it is a well-defined pattern of objects, well-defined collection of objects where we can say the particular name or particular number will belong to the set or not. I hope the definition of set is clear. Okay, so all of you, now what you have to do, take your maths notebook and write down sets. Written? Now here write down the definition of set. I am saying the definition, you just write down. Right? A set is a well-defined collection of objects. Once again I am saying a set is a well-defined collection of objects Well defined means whether confidently you can say that name or that element will be there in the set or not. Definition written? Okay. Now I will write some example and we will discuss whether it is a set or not. By seeing the pattern, if you are able to identify whether a particular number or name will belong to the collection or not. Okay. So now the first one I am writing. In this way, I wrote some numbers. So can you tell me whether 6 will come in this set or not? Yes, we can write 6 also there. So in this way, confidently we can say that 6 will be there in this set. So this one, this collection of numbers is a set. Clear? Okay. So now I hope the definition of sets is clear to you. So definition and this example also written. So you can write down there. Yes, it is a set. It is a set. So in this way we studied so many numbers there. So first we can define the set of all numbers there. Now instead of writing it is a natural number, we will denote it by that letter there. So all of you just write down first set of natural numbers. Set of natural numbers. Now we will denote it by capital letter. Set of natural numbers, we will denote it by capital letter. Set of natural numbers, here I wrote natural numbers only. Now next, in this number only, if I will add 0, here if you don't know, you can write down there. Set of natural numbers denoted by the letter N there. Always the set should be written in capital letters and its element, and this is the symbol which we have to use to represent set there. First, the set will be represented by capital letters and this symbol you have to use. This is called braces. B-R-A-C-E-S. So the element should be written inside this braces only. So first one, set of natural numbers 1, 2, 3, 4, etc. because it is infinite there. So first set of natural numbers. Then second one, in this natural number if I will include 0, then that will be set of whole numbers. So next write down set of whole numbers is denoted by the letter W. So here you can write W is equal to 0, 1, 2, 3, etc. You just put this symbol properly. This is the correct. When I will write fast, sometimes the symbols will not come properly there. This is the correct symbol, braces. Set of whole numbers written. In this one, I took only positive integers there. So now in this set only, if we will include the negative numbers also, then that is called set of integers. Set of integers, and set of integers is denoted by the letter not I, is denoted by the letter Z. So we will write Z is equal to 0, 1, 2, etc. This side negative numbers also. So Z will be denoted by the set of integers. Till here all have written. All of you, when you are viewing the class, do the classwork along with me only. Till here all have written? Okay. Next, in this set only, if I will include rational numbers also. 0, 1 by 2, 1, minus 1 by 2, minus 1, etc. Then this is called set of, set of rational numbers. Set of rational numbers, and is denoted by, not by the letter R, is denoted by the letter Q. Then next one, in this only if I will include irrational numbers also. Set of rational numbers together with the set of irrational numbers. Together we are saying this is set of real numbers, and set of real numbers is denoted by the letter R. So once again we can revise. These are our number system there. We'll start with natural numbers there. So set of natural numbers is denoted by the letter N, and the natural number starts from 1. 1, 2, 3, 4, etc. Then in the set of natural numbers, if I will include 0 also, then it is called whole numbers there. And set of whole numbers is denoted by the letter W. In the set of whole numbers, if I will include the negative numbers also, then it is called set of integers and is denoted by the letter Z. Then in this integers, if we will include fractions also or rational numbers also, then it is called set of rational numbers and is denoted by the letter Q. In the set of rational numbers, if we will include irrational numbers also. So rational numbers together with irrational numbers forms the set of real numbers, and real numbers is denoted by the letter R. Till here all have written? Okay. If now we will observe the pattern, the smallest number system which we have, that is natural number system. So we will write in this way. Smallest one is natural number. After natural number system we have whole numbers. After that what we have? Yes, we have set of integers. After that what we have? We have set of rational numbers, that is denoted by the letter Q. And after that we have set of rational and irrational numbers together is called set of real numbers there. So this is the format which we have. The smallest one is natural number system. In this way it will go. So if we will write in this way, then from here we can say whether every natural number is a real number or not, whether every whole number is a rational number or not. Now like example, can we say every whole number is a real number? Every whole number is a real number. Whole number means it starts with 0 there. So if I will write 0 here, can we say 0 is a real number also? Yes, 0 can be written as 0 by 1. Real number is a combination of rational and irrational numbers. So every whole number is a real number. Now in this way, every natural number is a whole number. Every whole number is an integer. Every integer is a rational number. Every rational number is a real number. So in this way we can say, but the converse is not true. We cannot say every real number is an integer, like root 2. Root 2 is irrational number. This real number is set of rational numbers together with set of irrational numbers. So here we wrote root 2. Root 2 is irrational number, but root 2 is not an integer. Root 2 is not an integer. So we cannot say every real number is an integer. So in this way we can say, if you will check the pattern, every natural number is a whole number. Every whole number is an integer. Every integer is a rational number. Every rational number is a real number. But every real number is not a whole number. So in this way, reverse order is not possible. Straight, everything is possible. Every whole number is a real number. Every natural number is a rational number. Reversing it is not possible. Now I think you all have understood this one. Okay. Just all of you just write down in notes there. You can put a note there. This I am giving you so that you can remember this one. Just write down. The set is always denoted by capital letter. Please write with me. The set is always denoted by capital letters. and elements in this set are denoted by small letters if it is a set of letters. So always elements should be denoted by small letters, and when you will write the set, set will be denoted by capital letter. Till here all have written? All you can check here. Here I wrote a set A is equal to 1, 2, 3, 4, 5. So here A is a set and 1, 2, 3, 4, 5 are called the elements of the set. Elements, or we can say objects, or we can say members of the set. A is a set with elements 1, 2, 3, 4, 5. Now, by seeing the set, can you say whether 4 is there in set A or not? 4 is there in the set A. So, here I am writing there 4 is there in set A. So, always it will be difficult to write in this way. 4 is there in the set A. So, instead of writing in this way, we will use this symbol. If the element is present in the set A, then we will write in this way. 4 belongs to A. This is a Greek symbol is epsilon. The name is epsilon and we will pronunciation is belongs to. Belongs to. So 4 is there in set A. Instead of saying in this way, if I will ask whether 4 is there in the set A or not, then you will say yes, 4 belongs to A. So all of you just write in this way. 4 belongs to, in this way. How we are writing E and then one symbol there. 4 belongs to A. Now if I am asking whether 6 is there in the set A, 6 is not there, then how we will write? 6 does not belongs to A. Clear? If the element is present in the set, then we will say the element belongs to the set. Otherwise, we will say the element does not belong to A. So, can we say whether 0 belongs to A or not? Yes, 0 does not belongs to A. Whether 3 belongs to A? Yes. So, we will write 3 belongs to A. So, if the element is there in the set, instead of writing in this way, we will use this symbol, belongs to. The name is epsilon. It is a Greek symbol there and the pronunciation is belongs to. So, if the element is there in the set, then we will say it belongs to the set. Otherwise, it does not belong to. Clear? Okay, so moving on to the next concept. Now next is, there are two methods of representing sets. First method is roster form. Write all of you with me, roster form or tabular form. First we can write the definition and after that we will discuss the example. Roster form or tabular form. Just write down in this only. In this form, elements are listed. Elements are listed. How many elements are there in the set? We will write down all the elements. That is called roster form. And second method of representation is set builder form. Set builder form. In set builder form, what we are doing? We are not writing the elements of the set. We are writing the property which is satisfied by the element of the set. So just write down there in this one, writing the property which is satisfied by the elements of the set. elements of the set. So all of you please write down here in roster form. Directly we are writing the elements of the set, and in set builder form what we are doing, we are not writing the elements there, we are writing the property which each element satisfy. It's not like that only one element should satisfy. All the elements should satisfy the property. So instead of writing all the elements, we will write that property there. Now we will discuss some examples there, how we can check. So all of you write down the first one. Now all of you, we will check how to write the elements in a roster form. So here I wrote one question there. All of you write with me. First one I wrote set A is equal to here. Now first what I wrote there, braces I used there. So here how we will pronounce this one. It will be pronounced in this way. These braces represent the set of all. The set of all. Where braces is written, pronunciation will be the set of all. The set of all we said, then X is written. Then we will say the set of all X. And here the colon which I used, that we will pronounce as such that. So if I will pronounce this question, it will be pronounced in this way. A is equal to the set of all X such that X is a natural number less than 10. Clear? How we will pronounce? A is equal to the set of all X such that X is a natural number less than 10. So I wrote in this way. But in roster form what we are doing? We are listing the elements of the set. So what we have to write? We have to write the natural numbers which are less than 10. So natural numbers starting from 1. So we have to write down all the natural numbers which are less than 10. 5, 6, 7, 8, 9. So over. We converted the given question in roster form. Now we will discuss the second example. Suppose I wrote in this way. B is equal to set of all X such that X is equal to 2m, where m is a natural number. Where m is a natural number. So again, pronunciation will be in this way. B is equal to set of all X such that X is equal to 2m, where m is a natural number. So already we know if m is a natural number, we'll start with 1 only. Okay. Now here the elements are denoted by the letter X there. So we don't have to write first m is equal to 1. What we wrote here, X is equal to 2m. So if we will take m is equal to 1, what will be the value of X? 2. So our first element will be equal to 2. If we will write m is equal to 2, then what will be X? Yes, it will be equal to 4. If I will write m is equal to 3, then X will be equal to 6. If I will write m is equal to 4, then X will be equal to 8. Now here m is a natural number only written there. There are infinitely many natural numbers there. So ending we don't know. So in this way you can put dash 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 to represent that it will go on continuation there. We'll discuss some more examples there so that the concept will be clear to you. Till here all have written? Okay. So all of you write the next one. Set C is equal to set of all X such that X is a positive integer. X is a positive integer and X square less than 40. So in C I wrote there, we have to find out X which is a positive integer and whose square, X square is less than 40. Now we can check. Since it is written there, it is a positive integer. We can start with 0. Okay. Whether 0 will be there or not. Here we will check. 0 square. 0. That is less than 40. Okay. So 0 will be there. 1. 1 square is 1. That is less than 40. So 1 also will be there. 2. Whether 2 will belong to the set C or not. 2 square is 4. And 4 is less than 40. So 2 also will come. 3. 9 less than 40. Yes. 4. 4 square is 16. Less than 40. 5. 5 square is 25. Less than 40. 6. 6 square is 36. Less than 40. 7. 7 square is 49. Which will be greater than 40. So we cannot take 7. So the elements will be in this way. C is equal to 0, 1, 2, 3, 4, 5, 6. Now hope the method is clear. Here next example already we wrote there. We'll convert into roster form. Here in fourth one it is written D is equal to set of all x such that x is an integer and minus 4 less than x less than 6. What is the meaning of this one? X is an integer which lies between, means x is greater than minus 4 but x is less than 6. I think if I will draw the number line then it will be easy for you to understand. Here we have 0, minus 1, minus 2, minus 3, minus 4. 1, 2, 3, 4, 5, 6. So what is given in the question? X is an integer. That's why I have drawn the number line there. X is an integer such that x is greater than minus 4 and x is less than 6. X is minus 4 is here. Greater than minus 4 means we have to go to right hand side. So our number will come from minus 3. And less than 6. Less than 6. So previous number is 5. So all these numbers are there which will satisfy this property. So directly we will write here D is equal to. What are the elements which we are getting? Minus 3, minus 2, minus 1, 0, 1, 2, 3, 4, 5. Here it is written in this way. X is greater than minus 4 but less than 6. Now it is clear how to represent in roster form. Okay, so next question already written here. E. E is equal to set of all x such that x is a 2-digit number whose sum of the digits. When we will write a 2-digit number, the sum of the digits should be equal to 6. So if it is a 2-digit number, the smallest one will start with 1 only. Okay. So 1. Whose sum of the digits is 6. 1 plus 5 only will be 6. So the first number will be equal to 15. Now if in the unit place I will write 2. Then what will come? Yes, 2 plus 4 only 6. So 24. Next which number will come? In the unit place I am writing 3. Then in the tens place. So 33. Then in the next place what will come? 4. 4 plus 2, 42. Then 51. And then 60. Any other number will come? 70? No. So this is the roster form for the given question. E is equal to set of all x such that x is a 2-digit number and sum of the digits. These are the digits. Sum should be equal to 6. So here we are getting the numbers equal to 6. The sum. Next it is written there f. Set f is equal to set of all x such that x is a factor of 36. So we have to write all the factors of 36. Means the numbers which divides 36 or 36 is divisible by which of the numbers there. So we'll start with the least one. 1. 1 is a factor of every number. 2. Whether 36 is divisible by 2? Yes. So we will write 2 also. 3. Whether 36 is divisible by 3? Yes. So we will write 3. 4. Whether 36 is divisible by 4? Yes. So 4 also we will write. Then 5. 36 not divisible by 5. So 5 we cannot write. 6. Yes. 6 6 are 36. Now order will be reversed there. 4 9s are 36 only. So 4 into 9. So directly you can write here 9. Then 3 into which number? 3 into 12. Then here I am writing this one to check the factors. 2 into which number? 2 into 18. Then 1 into which number will give you 36? 1 into 36. So here are the factors of 36. So in this way, if the property is written, we can write down the elements of the set. And writing the elements in this way is called roster form. Now we'll discuss some more examples there. Next example written there. G is equal to set of all x such that x is a prime divisor of 40. Divisor meaning factor only. So we have to find out x such that x is a prime factor of 40. It should be a factor and it should be a prime number also. What is a prime number? Yes, the number which is divisible by 1 and itself. So we'll start with 1. 1 is a factor of 40, but 1 is neither prime nor composite. 2, yes, 2 is a factor of 40 and 2 is a prime number. 3 is not a factor. 3 is a prime number but not a factor of 40. 4 is a factor of 40 but 4 is not a prime number. 5, yes, 5 is a factor and 5 is a prime number. So now we can check the prime numbers. Any other factor is there? 5 written. Then next factor of 40 is 6 not there, 7 no, 8 but 8 is not a prime number. Then next 8 5s are 40, 20. 20 is not a prime number. So only these two numbers are there which are prime divisor of 40, 2 and 5. Then next example written there. H is equal to set of all x such that x is a letter of your favorite mathematics. X is a letter of the word mathematics. Already the letters are written in capital, so we will write also in capital letters only. And you can check some letters are repeated there. So you don't have to write it 2 times there. If the letters are repeated, then also no problem. You just write once only. And order also not important there. Here if I wrote 2 5, you can write 5 2 also. In that order is not important. Only all the elements should be there in the set. So here what are the elements will come? Yes, M will come. So M taken. So M we can cancel there. Then A. So A also we have taken since it is repeated there. That's why confusion will come. T. So T also we have taken. Then H. H is not repeated. So we'll write it there. H taken. E. I. C. S. So H already we wrote the elements of the set. So writing the set in roster form is clear to you? Okay. So now we will move to the next one. How to write down the set in set builder form. Next question you can check. It is written write in set builder form. Elements are written. Now we have to check the elements satisfy which property and we have to mention the property, not the elements. Elements are already listed there. So by seeing the elements, what you are thinking first? What are these elements? 1, 2, 3, 4, 5. Negative numbers are not there. 0 also not there. So it is a natural number. And whether all the natural numbers are there? No. We have the natural number till 5 only. So if we will write the property, we will write in this way. A is equal to set of all x. Which property x satisfies? Yes, x is a natural number and x is till 5 only we wrote. So x is less than 6, or you can write x is less than or equal to 5. So instead of writing x is a natural number, we can write in this way: x belongs to n. N denotes the set of natural number. So if I wrote x belongs to n, meaning x is a natural number. And whether we have taken all the natural numbers? No. We have taken the natural number with till 5 only, means the natural numbers are less than 6. Either you can write less than 6 or you can write x less than or equal to 5. Both will be correct. So here in this way we will write A is equal to set of all x such that x belongs to n. Its meaning is x is a natural number and x less than 6, or you can write x less than or equal to 5. Both will be correct. So this is called set builder form, where we haven't written the elements. We wrote the property which is satisfied by the elements. This one is clear? Okay. So now next one is written here. B is equal to 3, 9, 27, 81, 243. So by seeing this one, can you imagine any pattern? We have to check the pattern which is followed by the elements of the set. Okay, 3. First one is written 3. 9. 9 is 3 into 3 only. Then 27, 3 into 9. So 9 is 3 square. Okay. So 9 can be written as 3 square. 27 is 3 cube. Then 81 is 3 raised to 4. 243 is 3 raised to 5. So just to check there, this number is same. If nothing is there, we can write 1. 3 is common in all. Which one is changing? Only the powers are changing there. So how we will write this one? B is equal to set of all x such that x is equal to 3 raised to m. X is equal to 3 is constant in all. That's why I wrote x is equal to 3 raised to m, where m is the power. And power changes from 1 to 5. So either you can write in this way: 1 less than or equal to x, m less than or equal to 5. So many methods are there to write the property there. So first one you can write in this way: value of m lies between 1 and 5. Either you can write in this way, and this one should be specified: m belongs to n. M belongs to n. Or you can write in this way also: m belongs to n and m is less than 6. Both will be correct. So x is equal to 3 raised to m. 3 raised to m, because here 3 is a constant, power only changes there. That's why I wrote the property for power only. M is a natural number and m less than 6. Or you can write in this way: 1 less than or equal to m less than or equal to 5, and m belongs to n. Clear? We'll discuss some more questions, then it will be clear to you. Now next, third one you can check there. I wrote the number 5, 10, 15, 20 in this way. So by seeing the number, what do you think? What property they satisfy? What is the pattern? Yes, they are in the multiplication table of 5. 5 ones are 5, 5 twos are 10, 5 threes are 15 in this way. So, set of all x such that it is correct, it is a multiple of 5. So, we will write x is equal to such that x is equal to 5m, where m represents multiple of 5. And value of m starting with which one? If I will take m is equal to 1, then only I will get here 5. Then if I will take m is equal to 2, I will get 10 here. So the smallest value of m is 1. So our value is starting with 1 there. So we can say m is a natural number. So we will write here m belongs to n. And since it is infinite there, still more numbers we can write there. That's why restriction is not there. Till where we have to take. So this is the property satisfied by this element. C is equal to set of all x such that x is equal to 5m, comma, m belongs to n. I hope the method is getting clear to you. Next one also, elements are listed there. We will write the property which is satisfied by the element. So here in fourth question you can check the numbers written 1, 8, 27, 64. In between numbers are there. The last one is 1000. So can you check these elements are of which form? Just to check it is in which form. Yes. First one is 1, that is 1 cube. Second one is 2 cube. Third one is 3 cube. 4 cube. In this way. Last one is what? Yes, last one is 10 cube there. Now here you can check. The power is same. Power is 3 only in all. Only the numbers are changing. The number 1, 2, 3, 4, 5, etc. till 10. So again 1 to 10 they are natural numbers only. So we will write in this way. A is equal to set of all x such that x is equal to m I am taking. If you want you can take any other alphabet there. It depends on you. So I am writing x is equal to m cube. M cube. And our smallest value of m is 1 only. So we can write m belongs to n. M belongs to n meaning that is a natural number. And whether we have taken all the natural numbers? No. We have taken the number till 10. So either you can write m less than 11 or you can write m less than or equal to 10. Both will be correct. You write any one there. So x is set of all x such that x is equal to m cube, where m belongs to n, meaning m is a natural number less than 11 or natural number less than or equal to 10. Both will be correct. The next example is a is equal to, here already written there, 3, 5, 7, 9, 11, 13, 17, 13, 15. Which type of numbers? By seeing the pattern? Yes, they are odd numbers. So odd numbers, how we will write odd numbers? X is equal to, even number we are writing it as multiple of 2. So odd number either 2m plus 1 or 2m minus 1 there. So if I will substitute here, m is equal to 1. Then 2 into 1, 2. 2 minus 1 is 1. But 1 is not there in this set. So what we will take? X is equal to 2m plus 1. Multiple of 2 plus 1. How I wrote in this way? Just to check there. If you will substitute m is equal to 1, 2, 3, 4, you should get the element there. So if I will take m is equal to 1, what I will get? 2 into 1, 2. 2 plus 1, 3. If I will take m is equal to 2, first I have taken m is equal to 1, then I got m is equal to 3. Then I took m is equal to 2, then we got m is equal, x is equal to 5. Then if I will take here 3, we will get 7. Then 4, 5, 6, 7. So value of m we have taken till 7 only. Starting with 1 to 7. So again what we will write here, m belongs to n. M is a natural number and m less than or equal to 7. Or you can write m less than 8. Both will be correct. And I think this property is clear to you. Next one is written, write in roster form. property is there, we have to write down the elements of the set. So as you can check, the first one, x is equal to set of all x such that x is an even natural numbers. So we have to write natural numbers which are even. So it will start with 2. Yes, 2, 4, 6, 8. Whether it will end? No. So we will put dash, dash, dash. So we wrote the elements. Clear? Okay. So now next one, just to check there. B is equal to set of all x such that x is an even integer. In the previous one it was written even natural number, and here it is written it is an even integer. So negative numbers also can be included. So we will write here 2, 4, 6, etc. Whether we can write 0 also? Okay, 0, minus 2, minus 4, etc. So even integers. Now here, the third one, set of all x such that x belongs to z. X belongs to z. What is the meaning of that? Yes, x is an integer. So remember that one. Z denotes the set of integers such that x should be greater than minus 3 by 2 and less than 11 by 2. So here it will be easy if we will convert into decimal there. Here we have 0, 1, 2, 3, 4, 5, minus 1, minus 2, minus 3. 11 by 2. If we will divide, that will come 5.5. So 5.5 somewhere it will be here. And minus 3.2. 3 by 2 means that will be equal to minus 1.5. Minus 1.5 somewhere it will be here. Minus 1.5. Now here we have to write the integers which are between minus 1.5 and 5.5. So what are the integers between minus 1.5 and 5.5? These are the integers which we have. So just write down that element. Minus 1, 0, 1, 2, 3, 4, 5. So in this way we can write down the elements of the set. So I hope today's concept is clear to you. In case of any doubt, you can call me or you can send the message through WhatsApp. So all of you please note down, your homework will be your first exercise. Exercise 1.1. The first, I think first, second, some questions you can do in your textbook only. You can mark the answers in textbook, but do with pencil. After that, when you will start writing the element in set builder form and roster form, that you can do in your maths notebook. Thank you.